Hi folks, so the questions we have in front of us here today, guys, are the short answer questions from the section A of the 2019 ordinary level DCG paper. Okay, so you can see here with 4 questions. As always, you have to do 3 of them, and we're going to work through them from A1 to A4 one by one in this video, starting with A1, which is up here based on the topic of solids in contact. So I'm just going to zoom into that one there now. Okay. The first question, A1, it says the 3D graphic below shows a modern sculpture in the grounds of Trinity College Dublin. It consists of a series of spheres which are in contact as shown. Obviously the largest one on top, then a smaller one, and the smallest one at the bottom. They're all obviously resting on top of each other, as we can see here, so we can see the points of contact between them. It consists, the entire sculpture rests on a square base, so we can see the square base here. Okay. The drawing on the right shows the incomplete projections of the 3 lower spheres, okay, in the plan view, centrally positioned on the square base. And it says part A, draw the given plan of sphere A. Okay, so we'll start with that. So sphere A is the largest one up here, and basically if you're looking down on top of it, obviously the other ones would not be seen because sphere A would be covering them. So this is actually easy enough. It's simply just a case of taking the radius from sphere A in your elevation, and take that radius as best I can there. Obviously I'm using a pen here now, so happy with that. And that should be larger than all the other spheres down here in my plan view, so as best I can, hopefully I don't slip here. So there is sphere A drawn in my plan view. Okay, nice and easy. That's drawn in my plan view there, and you can see then obviously the spheres underneath it then are in hidden detail. So that's part A done. Draw sphere A, done. Okay, part B. Draw the elevation of sphere B. So they've given us sphere B here. You can see there's another sphere kind of attached on up here at the top, a small one. When it has been moved into position C, so it has to go into this position up here, and as indicated by the arrow, so you can see the arrow moves in up here, so that it is in contact with sphere A at point P. Okay, so this isn't too bad. They've given us the point of contact, and any time you have the point of contact between 2 spheres, you'll actually see, if we just take this sphere and this sphere as an example, they're touching right here at this point. But what you'll notice is the relationship between the centers is that they are in line, where the 2 centers join to each other from here to here. Where they join will actually indicate the point of contact. So in this case, we have the point of contact. So if I draw a line out from my center, out there, through point P, okay, somewhere out along there has to be the center of sphere B. So all I'm actually going to do for that then is, I'm going to take the radius of sphere B. This will be a little bit awkward now, so apologies here. I'm drawing this because I'm using a pen attachment, just so it comes up a little bit clearer. So hopefully it can map onto it. And it's just about giving it to me. I'm just about able to reach it. So from point P, which is my point of contact, I'm going to mark that distance out there. And that distance right there, at that point there, I have now found the center of my sphere. Okay, sphere B in this case. So I'm going to do as best I can to draw that in. And bear with me now a second, because it's obviously a very small sphere. Dig it into the board here. So there's our sphere B, drawn in position C. So now we have sphere B drawn, okay, and then part C, so I'll tick off that guy there as well. And in part C, it's telling us draw the plan of sphere B as well. Okay, so now that we have sphere B in its correct position, it's simply a case, the center has to be directly below it, and it is also attached on off the side, and okay, so it's attached on at the side from the center. So once again, the center of sphere A, which is here, okay, remember the 2 centers have to connect, so if I connect that out, there's my center for sphere B. And I made a mistake earlier, because I'm going to take this and I'll explain more in a second. Sphere B, okay, which has been moved from here to here, is slightly above sphere A. So once I draw this in my plan, Okay, so I have that drawn in my plan. Hopefully it doesn't slip here on me. It didn't, amazingly. So once I've got drawn in my plan view there, I've now got sphere B here. Technically, this sphere is slightly above sphere A, which means that inside in here, this section in there, it's going to go over it again, that should be hidden detail in there, kind of like these guys are hidden detail as well, okay, because it's slightly above it, okay. I've used pens, but that's basically how it should be done. And now what we have to also do is just show the points of contact, okay. I would always show points of contact, but you haven't asked us first, but if the point of contact is here, you can also find it down here by projecting it down. That point of contact will be right there, okay. So that's our point of contact, also found in plan. Tick that off. Part A1 done. Bit of solids in contact there. Just a little bit of your understanding, obviously, of orthographic projection. So that's the question completed there, guys. We're going to move down now to the bottom of the page, which is on A2. Okay. Right, folks. So A2, it says here, the image below shows a coffee machine. The drawing on the right shows the plan and the partially completed perspective view of the main body of a similar coffee machine. Complete the perspective drawing. So as you can see here, they've kind of given us a partially completed view of it here. So just to kind of go over this and just give you the idea, I'm just going to put in a few lines here just by sketching them. They've kind of given us that drawing there, okay, is essentially this face here, okay. So they've actually given that to us. What we have to do is we have to complete the rest of the faces. So this face here, I'm going to start with this guy. That face there, okay, I'm going to have to complete him next. So you can see here I've already got this. Now, that face is going in this direction, okay. Therefore, the face is going to vanish to VP1, okay, because it's parallel, alright. So it's going to vanish to VP1 from where the spectator is, okay. And what we want to do is we want to be able to find that face. And I assume, just looking at it, so that point there, oh yeah, so it's in a little bit. So just be careful of this now, okay? So look at the drawing to see the stuff that, or the information it gives you. So you can see the base is actually coming out a little bit further. So you can see it here. The base is coming from this point. So that's another part of the base at the opposite side. Whereas the top portion is coming from here. And obviously here. So, to find where that finishes, you can see I extended it over. To find it, I'm going to have to bring this guy to my spectator. I generally stop them at the picture plane, just for neatness of drawing. You can see they bring it the whole way in, but I stop it at the picture plane. Where it hits my picture plane, what I'm going to do is just a little bit of sliding set squares. Project it down. And then it's a case of heavying in the information that's relevant. This is the first part. Okay, so that's the top bit done there. Now what I want to do is I want to complete the bottom bit. So for the bottom bit, I can see that this is probably going to be heavy. I'm using the round pen there. Heavy up to here. So heavy in this portion as well. So there with that bit. Now it's a case of finishing it off. So just using kind of, I suppose, your natural instincts, I suppose, a little bit. We can see that the lines that were going in this direction all vanish to VP1. So from this point here, it's going to vanish over to VP1. Okay. Lines that are going in this direction are all going to vanish to VP2. So this point right here is going to vanish across to VP2. Okay. Goes across there. And what you'll actually see is I'm finding, I suppose, the area where the cups are sitting, or the two little glasses. Okay, so we've got that, and at this point you might think it's almost complete, but we're just missing a little edge in here. Okay, so to complete that then, it's simply a case of, I'll use a bit of sliding set squares here. Okay, and at that point right there, that edge We'll go up there like that. Okay, so there we have it. That is our perspective complete. A nice little handy one there now. If you have a good understanding of perspective, you would have found that quite easy there. Okay, it's just a case of obviously vanishing it to the right points and work your way through the problem. So that is A2 done there, guys, on the perspective drawing. So we're going to move up to the top right now on A3. So A3, it says the images below show a cutter which is part of a paper punch. Okay, so we've all seen a paper punch before, obviously anytime you're putting something into a folder. Okay, it says the cutter appears as a parabola in elevation. So you can see here they've kind of got a detailed view of the cutter point. Okay, and they've shown it here, and what we can actually see is the parabola inside here. So that parabolic shape. So it says here the cutter appears as a parabola in elevation. The drawing shows the outline elevation of the cutter. So we can actually see it here. There's the outline elevation, but we're actually going to have to draw in the cutting part, I assume. And a portion on the left hand side of the parabola, which is inscribed in rectangle ABCD, is shown. V is the vertex. So we've already got some points here. Okay, it says part A, locate the remaining points on the left hand side. So we'll find these. Then we'll locate the points on the right hand side and draw the complete parabola. So if you know how to draw parabolas, it's something, if you're a junior start drawing at higher level, you would have learnt this. But you also need to obviously be able to know it for leaving cert drawing, okay, and DCG at ordinary level. So what we're actually going to do is just looking at this, just checking out distance there, 42. By the looks of it, they're going to be splitting it up, okay. So I'm actually going to use the same distances. I've already put distances in. Okay, for the parabola. So I'm going to take these distances here on my compass. Okay, that distance right there, I'm going to step it out because they've given me already the ratio. Generally I would divide the line up completely. I was thinking it would be 5, yeah. So there's 5 gaps, 1, 2, 3, 4, 5. 5 equal spacings. And like they did, I'm going to project my lines up. Okay, so them lines have gone up, alright. And what I'm actually going to do now is, the line AB, because I've divided up this line into 5 portions, I'm also going to divide the line AB up into 5. So just measuring that, it's 62, you can see here, from here up to here, it's 62 millimeters. So I'm actually going to use division of lines here. I'm going to step off. Now you could use a bit of maths, but 62 doesn't divide into it equally, so I'm going to step off in measurements of 10. So 10 fives are 50, so from 50 I'm going to mark 10s out. So 50 back to 40, 30, 20, 10 and 0. I'm going to connect this up to point B. And from each individual point after that, just a little bit of sliding set squares, division of lines, something you learn in first year. For every one of these, slips there myself now, so just mark that back up, slide that back down. What I've done here now is I've divided the line AB into 5 equal portions. Okay, so there we have it. We've divided the line AB from A here all the way to B here into 5 portions. Portion here, 1, 2, 3, 4, 5. 5 equal portions. Now anytime you have a parabola, they'll tell you the vertex, okay, and they've told us the vertex is at V. So every one of these points, okay, on the outside, I'm going to connect up to V. And hopefully that'll help me identify some points on my parabola. You'll see here now in a second. And this one seems to be working out. As you can see, that's giving me a point here. Now this one should go through here and connect to V, if I've been accurate. And it does. Okay, so to identify the points, okay, so you can see the first one, which is the furthest away from V, is connected to the line that's furthest away from V, and where it goes through, once connected to V, where it goes through gives me a point. Likewise, this one is the second one that's, I suppose, furthest on the line AB away from V, okay, and where that goes through, the second line that's as far away, or sorry, furthest away from V gives me another point. So likewise with the third one, is going to go into the third line. That gives me another point, and the fourth one into the fourth line. And as you can see, we have now got our parabolic curve. So I'm going to sketch that in. So that's nice and easy there. Having found that, or sorry, having completed that on the left hand side, it said there locate the remaining points on the left hand side, which we have done. Now it's saying locate the points on the right. Now I could go through that whole process again, but it's very, very easy because it's parabola. The points need to be the same distance out on the opposite side. So what I'm going to do here is just a little bit of axial symmetry to help me out. So, axial symmetry, using the axis line, V going down, I'm now going to identify some points on the right hand side. So I'm going to take the distance from the axis to the point here, mark it out, like that. Same thing here, take that distance, mark it out. Likewise, next point, take that distance, mark it out. And finally with the very, very last one, hopefully my compass reaches it, I think it will, just about there, as you can see. And I'm going to mark that out, the opposite side, and there we have it. So I've located now the points on the right hand side, so click that, tick that, draw the complete parabola. So now it's just simply a case of sketching the parabola in. So nice and quick. So there's our parabola, and it's just a case of finishing it off as best I can. Take your time with it, make it presentable for the examiner. Try and do it better than I am in one smooth stroke if you can. And there we have it. Okay, there is our parabola, and that is the cut section obviously of our hole punch. Okay, so that is part A3 completed there, guys. So what we're going to do now is move down to the bottom of the page and complete A4. Okay, so A4, it says the image below shows an artist's impression of a structure in their Centre Parks holiday resort currently under construction in County Longford. The drawing on the right shows the outline of a similar structure. So you can kind of see the structure here, and that's what they're trying to represent over here. It says here the design of the structure is based on lines and tangential arcs. Okay, so just lines and arcs. The structure has a uniform thickness. Therefore, the thickness is the same all the way around, okay, for this bit here. And a small portion of the inner parallel surface is also shown. So we're given the outline, okay, the outline bit. I assume what we have to do is we have to complete the rest of it inside in here, okay. And as we said, it has the same thickness, so we have the thickness here. Complete the drawing of the inner surface and then show the exact points of contact between all arcs and lines in the structure. Okay. So what we actually are going to do is they've given us, just to identify, this portion from here to here is actually a straight line. Okay, that's the first thing we need to identify. And then what we've actually got here then is an arc here, okay, which will be based off the center point here for a circle, so but we only need the arc part of it. And then we have another arc here, okay, and with the center point for that. So what we actually do is, first of all, I'm just thinking, this is actually something you might have learned in second year technical drawing. I'm going to go perpendicular from the side here. So I'm given the side, and through the center point I'm going to go perpendicular to that, just to identify my radius length. So from there, and I'm also going to extend on this line here perpendicular as well. And extend that on, and that obviously goes heavy up to there. But what's important to note about that is, because I've got the perpendicular distance, I actually have the radius, which is really, really important there, of the outside arc. But now I've also got the radius of the inside arc, which is really, really helpful. Okay, so using my compass, I'm just going to draw in that as best I can. So from here to here, I've got that radius. I'm drawing that lightly first. As you can see, I've extended on the arc, and that's okay. And what I also need to do now is, just looking at that, I now have to get an arc going from here that is uniform and tangential to that. So I suppose the same arc, if I connect the two centers, yeah, that'll actually do it for me. If I connect the center of this arc, of the big arc, to the center of the little arc and extend it on through, that will give me the radius from this one to this one, okay, for the inside portion. So just put that in now as well. So using my compass once again, up to here, and hopefully this works. And you can see here, yeah, it's staying uniform the whole way. So you can see I've got the inside part there now. So that actually wasn't too hard. It just takes a little bit of use a little bit of your understanding. And I'm going to heavy that in now. I've probably done this previously. It's just good to be sure. So obviously in the day you'd be doing this lightly with pencils, then going over it. So I've got that bit heavy there. Now I'll heavy in this portion. Just make sure I'm 100% on it there. So there we have it. That is the inside portion. Okay, so we've completed that bit. Now it says show exactly the points of contact between all arcs and lines in the structure. So we've got a point of contact right here between the line and the arc, and we've also got another point of contact right here. I suppose if I was to extend them on, that's the inner structure. And I'd also have a point of contact here between the outside arc and this outside arc. So where they meet is right there. Likewise here with this line. Okay, so POC, POC, point of contact, point of contact, point of contact. And then between this line here, I suppose there's technically points of contact there as well, but they're not tangential, okay? So these ones are tangential there. And yeah, that's basically that question complete there. So we've shown all the exact points of contact between all arcs and lines in the structure. Okay, that one wasn't too tricky, just taking a little bit of figuring out there. Okay, so that there, guys, is the 2019 short answer questions in the ordinary level paper. Hope you found it helpful.